Good afternoon. In this video, we will solve a real-life problem using the 4Sight and the Genii calibrator. We have a problem in the field that there is a pressure transmitter located in tag 31A has failed. This tag is located in the water treatment area in refinery 1. This tag is very critical for the process, so we have to utilize something else to perform the measurement. Unfortunately, there are no new transmitters, so we'll be using a previously used one till we get a new supply. So that's our issue now, that the old transmitter is from Yokogawa, required to measure 0 to 40 bar gauge and provide a calibrated output of 4 to 20 milliampere respectively. And these should be documented in the system, of course, to follow the compliance rules. The transmitter maximum working pressure is 100 kilogram over centimeter square. So obviously we need to make a rearrange for the transmitter to perform the calibration, the task. So what would be the plan for us? We will be using the 4Sight, the Genii multifunction calibrator with hard communicator and the pressure station, which is part of the kit, and a pressure module. So first we will register or add the new transmitter to the system. We will rearrange the transmitter to the desired range using the hard function in the calibrator. We have to perform the as found calibration, then do adjustments if necessary, and finally perform the as left calibration and generate the certificate. So that's our plan for today. Let's now start with the 4Sight software. So as we access, I'm already logged in as an administrator. Let me start over. So I'll be logging in as an administrator, or someone has an admin rights to perform, to be able to add and remove tags or assets from the system. So here's the asset management. Under the 4Sight, we have multiple sites. We'll go to the refinery 1, water treatment area, and this is our tag 31A. Under this tag, we will be adding the device. So here we have the new device, high priority device, device name, let's say main water tank pressure, or main tank pressure. You can add description the way you want. The maintenance date means the last day it was calibrated. We don't know, so we'll put it a year back, so it will appear as an overdue in the system and got the priority to get calibrated. Device ID, asset ID. These are all information you can fill if you are following a certain rule in your asset management. The device type, it's a pressure device. Manufacturer, Yokogawa. Model number, YTA pressure. Serial number 5161238. And then you can add these corrections if you want. You can put some calibration notes for the people. So you can put warning. Let's put a warning, for example, high pressure. This will appear in the operator's menu when he wants to perform the calibration. Pre-calibration node, isolate the inlet before calibration. Post-calibration node, pressurize the line. So we have created the device. Now under the device, we can create multiple ranges. So for example, we can consider the display calibration as a range, the loop calibration as a range. So in our case, we need to do a calibration for the loop. So the range name, let's say 4 to 20 milliampere loop. Okay. The relationship between output and input is linear. Settling time between the points, let's say it's 10 seconds. Then we need to define the input and output. The input, in our case, is pressure, 0, 140 bar. The output is electrical, it's 4 to 20 milliamp. The reference mode, you can select, depends on the device you have. In my case, I'll be using the sail gauge turbs because I'll be using a turbs pressure module. Then we have to define a percentage for pass and fail. So let's say 0.2% as a pass fail span. Then we have a span for adjustment. So the span for adjustment, if I wanted to limit the adjustment to a certain limit, beyond that I will not allow it. The people should report it. I can define this as well. The routine, how frequent it requires to be done. You can create your own routine. We have the common one, annual, monthly, every 6 months. So let's say it's monthly. So it's every 30 days. Procedure, we have 3-point calibration, 4-point calibration, 5-point. Let's select the 3-point calibration. So it's, if we click on the eye here, it will appear that 0, 50, and 100%, then 50 and 0. You can create your own way if you want. If you are not okay with this, you can create your points by create procedure, or you can use the preset ones. Now, create. So my asset has been created. Let's go to assets. So you can have a view here. Our device here is overdue. So as you can see here, I filtered by needs calibration. I got all the devices which require calibration. So for me as an administrator, I can assign them to the people. So this task I'll be assigning it to one of my team. So I'll assign it to Mike to perform it. So he's a technician, and I'll put myself as an approver. Now the task has gone to Mike to perform. Let's sign out and log in as Mike. So Mike will sign in either from the same computer or from his own computer if the software is installed on a server. He will go to the assets. He will find the pending tasks for him. So here are the notification of the tasks pending for him. So he has to perform these 3 calibrations. Let's say that he wanted to do them using a portable calibrator, because as we discussed, we will be using our DPI620 Genii. So this is the task. He will move it to a portable calibration. Then he will send all the devices he wants, or all the tasks he have. He can assign it either to a portable calibrator, manual or automated calibrator, depends on the equipment he is about to use. In the calibration, you will find all the tasks to him on this. So this task, we bring our Genii now. We connect it through the USB cable. We will see that when we go to the video and refresh. It will show all the devices connected. So here is our calibrator. It's overdue, okay, because this is a demo purpose. So we will allow this. By the way, you can disable this, so you can prevent people from using overdue devices from the system management under global policies. So you can set up the environment. So it's 30 degrees Celsius. So the humidity is 85. Then this task, I need to move it to the test equipment. So send to test equipment. Again, a warning, overdue. So the task was processed and sent to the calibrator. Now we will be moving to the calibrator and continue So we are now done with the 4Sight. I just finished and removed the USB cable from the device. We will start now our task. So this is my transmitter. I'll be connecting that to the Genii. Use the hard function to start and do the rearrange to set it up 0 to 40 bar gauge, then start performing the calibration. So the devices of Druck are all ready for quick fit. So this is the transmitter, half-inch. I already put the half-inch quick fit using my tools on my Teflon without putting any tools in the calibrator side. Now, if I move to calibrator side, I'll use the Titan by hand only. So it's very easy and prevents a damage for the device under test when performing the tighten and untighten, and avoid human errors which might destroy the port and required repair for the calibrator. So this is my transmitter. As we can see, there is no power here, so I wanted to power it from the Genii itself. How did I choose the connections here? You can always go to the help menu from the dashboard and connections. You have guide for all the connections. You can check the manual, or you can see one of the videos I have. So I'll put a link in the description box below for a video how to put the right connections. So I'm using the DBI620 Genii-IS. So this is the proper connection for heart. Now from the dashboard, I'll go to heart. I need power supply and I need a heart resistor. Both of them are not there in the loop. So from the settings of heart, I can choose the heart resistor. So okay, pressure module will be used as seal gauge. I will vent the pressure. So that's the necessary point to be done when you connect an absolute pressure module. You can use it as absolute or gauge. Here I'm using the TERBS pressure module range 100 bar absolute. Settings, heart resistor, you can add or remove. So here I added the heart resistor. You can use the sophisticated or generic heart mode. The power supply, I already got it from channel 2. So to get a power supply, you need to swipe, go to custom task. On channel 2, you need to select measure of current with a loop supply. So that's what is required. Then I'm ready now to go to heart. So the device is already powered. It has a milliampere, and I have the heart resistor. As you can see, the icon here is part of the package. So click on heart application. And then we can start performing the heart communication. So this is the task I uploaded. So why we use the heart now? To make the rearrange. So I'm here on the main screen, online, device setup. Okay, let's do a basic setup. So you can add tag, unit, etc., damping ratio. In our case, we want to make a rearrange. So we can do a rearrange either by applying values or by the keypad input. So the device was previously used to perform 0 to 10 bar measurement. We will rearrange the URV. So the low is 0, okay. The URV is 40. Set. Loop change warning, okay. So now LRV 0, URV is 40, unit is bar, we are fine. It's not applied yet, so we will use the tick to apply. So now the new settings has been stored to the transmitter. Now we can start our calibration. So we will exit the heart. Then we will go to 4Sight software. Here is the icon for 4Sight. You have here all the tags or the tasks moved to that calibrator. So ours is 31_A. So first we have the location. Go to refinery water treatment. Input is 0 to 40 bar. Output is current 4 to 20 milliampere. Number of points 5 points. 0.2 the tolerance. User is Mike. Serial number. Here is all to verify the information. You can change any of these if the site conditions changed. So we will change this to, for example, 27 degrees Celsius, and then we can start our calibration. So I got a warning, high pressure. Then pre-calibration, isolate the inlet before calibration. We already isolated, or it's already isolated. So we press on start, check test details. We checked already. Start. Now we can start the pressure calibration. Connect device under test. Here we connect the loop. So this is the same you can do from the calibration task, but the calibration will do the task without documenting that. Our purpose is to perform the documentation into the 4Sight software. So here is the pressure module I'm using. Of course, I'm using the PV622 pressure station, which can generate from vacuum to 100 bar. And I'm using the high accuracy pressure module, the TERPS module, range of 100 bar absolute, or 99 bar gauges. So we will go here, 4Sight again, select the function, start. So it requires P1, exactly. You want to use the module as a sealed gauge, yes. Vent to atmosphere. So that will allow me to put the new datum for the sealed gauge. Depends on the ambient pressure I'm having today. Now we are done. We can start the calibration. So our device is connected, and then we can start the procedure. So that's our procedure. I just showed you how to perform a sealed gauge. Now I'm ready. This is my calibration menu. So what's beautiful on 4Sight, it will tell you what to do. It will capture the readings, it will calculate the error without a single effort from your side. So as you can see here, guys, we have the device. The input is pressure, the output is loop. Both have green indicators, means that both are within the limits. Now we will be performing the calibration. So the first point is 0. The set point is within the limits. Save. Now it will say go to 20 bar. So we have to go to the next point. Of course, the station is designed for 100 bar. As you can see here, I am putting pressure. Every stroke will put around 1.5 bar. This will allow me to put points in the middle and simply perform a precise calibration between the points. So here I'm using the stroke pump to put pressure. The display is displaying the reading and the milliampere is measured by our system. Now the stroke pump starts to become hard, so we'll be using the wheel to go to 20. Now the wheel is free, it's very easy to operate, so we should put a primer pressure, then we should go and use the wheel, which will make our life easier. So here is our calibration. So we have got a 20 bar, 20.03, it's within the limits. And the output is within the limits. At 20 we got 12 milliamperes, it's fairly good result, it's within the tolerance. So the error is 0.01 and our tolerance is plus minus 0.2%. Press on this, so it will store the point. Now go to 40 bar. Now I don't have to use this, I can add more pressure simply by rotating the wheel in a faster way. So it will decrease the volume inside and add more pressure to my chamber. Yeah, so here we go. We are almost at 40. And the milliampere is within the limits. Save. Now go to 20 because our calibration is up and down. So as you can see, just a single rotation will decrease around 1 bar of the pressure. This will give me a very fine control between the points. If I wanted to perform, for example, a switch test, where I need to be precise at the switch latch and the unlatch point. So if I want to drop the pressure faster, I can open the vent. But in my case, I just wanted to show you the fine control for that. Now it's almost to the set points. 20.0003, so I'm fine, 12 milliampere. Great. Then go to 0. We will simply vent the system. And we are done. Let's wait for the pressure to go to complete 0. And the milliampere is within the limit. So the error is 0.1%. If the error was, or let's say the accuracy required is more, definitely we'll get an error here at 3.89. But in our case it was good. I'll show you now how to perform an adjustment if there is an error. In our case there was not, but let's see. So here I can post calibration notes, pressurize the line, I can return the line to operation, I can put my remarks, or I can put it on the calibration software. So here is done. Let's just see. So now, as found calibration is passed, I can look at the results in a form of table or in a form of graph. I can also see the calibration points. So we will not perform as left because our as found is pass. So we are done. Bye. Okay. Exit procedure. Yes. So we are done now with the calibration. Now we will go to make all other calibrations on the field. At the end of the day, we can come back to the software and upload the results to the 4Sight. We will see that together after we are done with the machine here. So I just wanted to show you, if you found an error, how to perform adjustment. So in hard devices, you either have potentiometer here to perform zero adjustment or full scale adjustment. You can make a zero trim, pressure trim, or you can change other functions. So we will come to see that together now. So here is our hard menu. We will select here hard. As you can see in the device, there is hard, field bus and profibus. In my case, I'll use the hard because my transmitter is hard transmitter. Then I can log in and perform the adjustment if required. So let's just quickly navigate through the hard to brief you about the functions you have in that. So anything in red we cannot change, anything in blue is coming from the calibrator side, anything in black is editable. Here are the information. So under the device setup, I have process variables, diagnostics, services. I can do a test device, self-test or master test. These all are enabled or disabled by the manufacturer of the transmitter. Calibration. In calibration, we have the rearrange, which we have did before. And by the way, you can perform a calibration and adjustment at the same time, thanks you have a calibrator and communicator at the same time. So instead of doing the keypad input for LRV and URV, you can put apply values, the device telling you to go to 0 or the LRV, then you use the calibrator to go to 0, then go to URV, you can pressurize 40 bar like what we did, then you perform calibration and adjustment at the same time. This will save a lot rather than keep connecting calibrator, communicator, calibrator, loop calibrator. You have everything in one kit. Then we have the analog output trim. You can perform digital to analog trim. Pressure sensor trim. You can trim the 0 point or the full scale point. Again, in basic setup, you can change the tag, change the unit factors, the pressure damping. Then, in detailed setup, you can perform some more features. So you have the loop test, you have the indicator, bar indicator. If you want an indicator instead of readings here, you can change the units, you can perform just the temperature sensor inside. So that's the task engineer. So thank you for that. We are now done with the calibration. We will go back to the PC to document that reading and generate a calibration certificate. Thank you. So he will come back after he finishes tasks, log in with his username and password to 4Sight. Just to show you, when you look at the KPIs and the asset health, there is one tag which is in progress. That's the one we have. If we go to calibration now, these are the tasks assigned to Mike. He only downloaded this one to the calibrator, which is the arrow is green. So he will connect. I already connected the device through the USB cable. Search. I will have my calibrator. Okay. Continue. Now I have results here. So this is the range I have. I now need to receive the data from test equipment. So this will upload the data from the test equipment to the PC. Again, a warning that my device is overdue. And again, to remind you, if you worry about that, you can disable that from the system management. So you can deny, or you can prevent the people from performing calibration with overdue devices from the global policies. So that's the way to get. So now here, press on. This one is to toggle. This is to send and receive from calibrators. This is to review. Now we toggle it. We have one data to review, which is the one we just uploaded. So these are the results. The as found calibration is passed. No adjustment required. Set point, actual input, actual output, deviation, error percent, pass or fail, uncertainty and uncertainty. Then a graph between the. So it's almost linear, but it's within the limits. So this is the graph for the error. The error is increasing, but it's not exceeding the full scale. So we are fine. Continue. So we don't have as left calibration because as found is fine. So in this case, the as found as left is considered the same. So we can copy as found and as left, or you can simply skip to summary. And the summary will show you it's done with these devices, with these. This is the pressure module. This is the Genii, which measures the milliampere. And this is the note we added in the calibrator successfully. I completed this calibration. This will have a digital signature for Mike at this date and this time that he performed the calibration. Again, another warning for the overdue. So now the device is calibrated. Let's now review the calibration certificates. So our serial number, we can look by tag number 31. You can search by serial number, but this is the device. So these are our results. And this is the trend. As we do the calibration many times, we will have a trend analysis, which will show the change in performance over time for the device. And the data is stored. No need to worry about box files, printing, etc. Everything is on the system. In case you need any certificate at any time, you select the calibration date and actions generate report. The report will be generated as per the template you have. You are eligible for a customized templates when you buy the 4Sight software, depends on the license you have. So you can have your certificate the way you want. You can have it as a form of a label. If you want to have a label printer, you can have two templates, one as a certificate, one as a template. You can have three, one for auditor, one for internal, and one for a sticker. So it's up to you. That's the flexibility we have. So that's our report. It was generated as PDF. So here is the report. As we said, it's fully customizable, but this is a demo version we have. So that's the way we perform the calibration adjustment documenting using using Genii, which has calibrator and heart plus 4Sight software. Thank you very much, and please feel free to put your questions in the comment section below or reach out for a price quotation. Thank you once again.